Lesson plan. Table of content. Famous marble monuments: Taj Mahal, Parthenon, Michelangelo's David. Guiding question: how does a simple sedimentary rock like limestone transform into one of the most prized stones in human history? Students will understand what limestone is, how it forms, and where it is typically found. Introduction. Let's start with a question. Have you ever seen a chalky white rock or cliffs by the sea? What you may have seen is limestone, a common type of sedimentary rock. What is limestone? Limestone is a sedimentary rock, which means it forms from materials that settle in layers over time. It is mainly made from calcite, a mineral with the chemical formula CaCO3, calcium carbonate. This calcite comes from the remains of marine organisms such as shells, plankton and coral skeletons. Brain quick fact: over millions of years, these tiny organisms die and settle at the bottom of the ocean. Their remains accumulate, get compacted, and form limestone. How does limestone form? Let's break it down, step-by-step formation. Marine organisms like coral, algae, and plankton live in the sea. When they die, their shells and skeletons, made of calcium carbonate, sink to the ocean floor. Over time, more and more of this material collects in layers. These layers are compressed under pressure and slowly turn into solid rock, limestone. Fun fact: some limestones even contain visible fossils. Where is limestone found? Limestone is typically found in depositional environments such as water-wave warm, shallow seas, coral reef, spiral shell areas with lots of shells and marine remains. These environments are perfect for supporting life that creates calcium carbonate and allows it to settle and build up over time. Quick recap: white heavy checkmark limestone is a sedimentary rock made from calcite, CaCO3. It forms from the remains of marine organisms. Found in warm seas, coral reefs, and shell-rich environments. Interactive check, optional, 1 minute. Ask a few quick review questions. What is the main mineral in limestone? Calcite/CaCO3. Where do the materials that form limestone come from? Marine organisms. Name a place where limestone might form. Coral reef, warm shallow sea. What happens to limestone? We learned that limestone is a sedimentary rock formed from the remains of marine organisms. But, what happens when limestone is buried deep inside the earth? Well, heat and pressure can transform limestone into something even more beautiful: marble. The process of transformation. Here's how it works. Deep in Earth's crust, there is intense heat and pressure. This heat and pressure change the limestone, causing the minerals inside it to crystallize and form new textures. Calcite crystals grow. The primary mineral in both limestone and marble is calcite, CaCO3. When limestone turns into marble, the calcite crystals grow larger. These crystals rearrange themselves, changing the rock's texture to a more smooth and glossy surface. In marble, these large crystals give it that beautiful, polished look. Colors in marble. But wait, marble can be more than just white. The color of the marble depends on the impurities found in the original limestone. Green marble gets its color from a mineral called serpentine. Black marble may have carbon from organic materials. Pink marble comes from iron oxides mixed in. Let's recap. Limestone changes into marble through heat and pressure deep in the earth. Calcite crystals grow larger and change texture, creating a beautiful, glossy marble. Different impurities in limestone lead to colorful marbles, like green, black, or pink. Quick check-in: what happens to limestone when it's buried deep inside the earth? What causes the colors in marble? This lesson helps students understand how transformation or metamorphic rocks form and introduces some cool aspects of marble's color origins. When we talk about where transformation, or metamorphism, happens, there are two main places to remember: plate boundaries, especially mountain building zones. Imagine two tectonic plates colliding. The rocks caught in between get squeezed and buried deep underground. This pressure and heat transform the rocks into new types, often forming metamorphic rocks like schist and gneiss. This is called regional metamorphism because it happens over large areas. Contact zones, near magma intrusions. Now picture magma pushing its way upward into the crust. The hot magma doesn't always reach the surface, but it bakes the surrounding rocks. This localized heating changes the minerals in the nearby rocks, creating new textures and structures. This is called contact metamorphism or transformation, and it usually happens in smaller, localized zones. So, long story short, at plate boundaries heat plus pressure widespread rock transformation. Near magma intrusions intense heat localized rock transformation. Throughout history, metamorphic rocks have been widely used in art and architecture. For example, marble was prized by the Greeks and Romans for statues and temples because of its beauty and ability to be finely carved. Slate was also used in historical buildings for roofing and writing tablets. In modern times, these rocks are still important. Marble and granite are popular in sculptures, monuments, and high-end construction. Slate is used for flooring, tiles, and countertops, thanks to its durability. But we also need to consider the environmental and economic impacts. Quarrying these rocks provides jobs and resources, but it can also damage landscapes, create waste, and use large amounts of energy. Sustainable practices, like recycling stone, reducing quarry impacts, and using alternatives, help balance human needs with environmental care. What conditions are required for limestone to become marble? Quiz test. How does limestone transform into marble? The correct answer is with heat and pressure deep in Earth's crust. Recap: marble's beauty lies not just in its appearance, but in its geological story, from tiny marine creatures to towering monuments. Thank you for your time in this course. Hope you enjoyed.